Okay, in this problem, number 2, it's going to be a little bit trickier because it has some friction in the problem, but you'll also notice that there's only 2 boxes instead of 3 boxes, so that simplifies it a little bit for us. Okay, so what do we have going on here? So 2 crates are in contact with each other, and a 750 Newton force is applied on the smaller crate. So it's kind of like an FA equals 750, and this crate is 80 kilograms, and this one is 210. And then it says the coefficient of friction is 0.14. So there's friction in this, so 0.14. So before I go too far, I want to add friction to my picture. So to do that, we are going to have to take each box and find its FW. And I'm going to write that down a little bit. So FW is mg. This turns out to be 784. And for this box, it turns out to be 2058. And remember that FW equals Fn. And the reason that we care about that is friction is mu times Fn. So really we could do mu mg. So basically friction is going to be mu times whatever these values are here. So let's write those in our pictures here. And I'm going to draw the frictions down here at the bottom. So there's friction between the 80 block and the table, and that frictional force is going to be 109.76. 109.76, and then there's friction between the 210 block and the table, and that turns out to be 288.12. All right, just like before, we are trying to find the force that the 80 pushes on the 210 and that the 210 pushes back on the 80. We're trying to find the force between the blocks in contact with each other. And in order to do that, we first have to find the acceleration of the system. So I'm going to start by thinking about the whole system. So we'll write down F net equals m net times A. Let's do the easy part first. Add up our masses. 210 plus 80 would be 290. We're going to be solving for A. And F net is what makes it move. What makes it move minus any friction or any blocks that you're dragging that might be hanging off the table or something, which we don't have. But we do have friction here and we have friction here. So we have to subtract both of them off. So we'll do that. And then we find out the acceleration is 1.214 meters per second squared. So we'll store that. And then we can start to tackle the force between the 2 blocks. So I'm going to do that by drawing a free body diagram of each block individually. So I'm going to do the 210 here. So let's call this 210. We'll make this one a little bit smaller. He's the 80 guy over here. All right, so on the 210, if I turned it into a dot or a point mass, I would have some FW and I would have some FN, but again, we don't care so much about that in this particular problem. So I'm going to write down F net equals MA. We know that the mass of this block is 210, and we know the acceleration of everything in the story is 1.214. All right, this is the harder part. We have to think through the F net. So sometimes it helps to go back to the big picture and like, what do we see up here? So first of all, I see friction going backwards. And so I'm going to come down here and I'm going to draw friction going backwards. I could draw it off the dot up here, or again, sometimes we draw it off the bottom. All right, so this friction is 288.12. And because I'm pushing on the system, I'm expecting it to go this way. So there has to be something pushing on the 210 that's making it go that way. Of course, it's the 80. The 80 pushes on the 210. So I'm going to label that the force of the 80 on the 210, and I can see that it goes to the right. So down here, I'm going to label this, and I'm going to make it a bigger arrow because I know that the block is going that way. This is the force that the 80 kilogram block exerts on the 210 kilogram block. And so that helps me figure out what I need to put in down here for the F net. It's going to be the force of the 80 on the 210 minus the friction, 288.12, and then I can find that force of the 80 on the 210, and it's 543 newtons. So we'll circle that. All right, now I'm going to go back and I'm going to put that in my picture. So this is 543. So that means that the 210 must push back on the 80 at 543. Newton's third law, they're equal and opposite. And technically, I have all the answers that I need that are on the piece of paper, but sometimes we're asked to prove that our answers are correct by checking it on the last block. So we're going to take a second and we're going to do that, and we're going to check it on this last block here. All right, so on the 80 block, what's going on? Well, we have a big 750 going this way, so FA equals 750. We have some friction that's going backwards, that's 109.76. And we have this 210 block pushing to the left at 543. Again, 210 pushing to the left at 543. So I need to add that to my picture down here, that there is a force to the left of 543. So now I'm going to write down F net equals MA. And I'm going to write it a little bit lower here so I have some space. So we'll start with the M. This is 80. And the acceleration is 1.214. 1.214. All right, F net. I expect the whole system to be going to the right, so this is going to be the 750 minus the things that are pointing to the left, minus 543 minus 109.76, and I multiply out this side, and I multiply out this side, or subtract, and compare, and if they match, then I know that my answer, or at least I feel pretty confident that my answers are correct. Okay, so hopefully that helps you solve that problem.